Okay, so we're going to do a quick review of Module 2 of rational numbers. These are your standards. Okay, so the first one is classifying rational numbers. So before we get to classifying, just recalling the rational number is basically A over B, right? Where B is not equal to 0. That means that we just basically write as a ratio comparing two quantities, right? It's basically a fraction, and remember, a fraction is basically a division. So let's start with this problem right here. So we have 4 friends, and let's just say divide. They don't die 3 cookies because that'd be funny. So 4 friends divide 3 cookies among themselves. What is a division? What division represents this as a fraction? Okay. Now we are gonna write the total, right, amount how many parts we're dividing that into. Okay. So we know that we have 3 cookies because that's what they're dividing, right? They're not cutting the friends for the cookies, but they're actually chopping the 3 cookies that they have, right? And they are divided in how many equal parts? 4. Okay. So the division representing this situation will be 3 over 4. Okay, 3 4. So that means that every if we have a chocolate chip cookie, right? We're gonna cut it into 4 equal parts, and then each of the friends is gonna get three quarters of the cookie. So basically that. Okay, so they're gonna get 1, 2, 3/4 of the cookie, and this is a division because remember the fraction bar basically means division, and it was the same as if they had 1, 2, 3 cookies, and they have to divide into 4 friends, so they're gonna cut each one of them into 4 friends, right? So let's pick different colors for each of the friends so you guys can see it more visually. Okay, so let's pretend that this person's gonna get 1, right? And then we have the next person gonna get 1 of each parts. Okay, so we look at each if we look at each one of them, every person has 3/4, right? You see 3 of those. Okay, so that's how we have 3 cookies divided into 4 friends, that each one of them is gonna end up with 3/4 of a cookie. Okay, so let's get to actually classifying. So we, as of right now, the numbers that we know are rational numbers, okay, and they can be fractions or decimals. Integers have to be whole numbers, or their opposites cannot be fractions or decimals, and whole numbers have to be positive, right? So 0, 1, 2, 3, 4, 5, all the way to infinity, okay? So we're going to look at these numbers and we're going to see where they fit. Now, negative 13, of course, a rational number, but is it an integer now? Yes, it is, because it's, let's say, have a decimal, it's not a fraction, so I can have negative 13 right here, okay? Now, you guys remember I can go from the outside, from the inside out, right? So all the integers, so this one is an integer, but it's also a rational number, okay? All integers are rational numbers, okay? Now, I cannot say that it's a whole number because it has a negative, so you cannot go in, okay? It's kind of like more qualifications that need to be met. Okay, 3/8. Now, I know this is a fraction, and that's going to end up with a decimal if I turn it into decimal. So this one is just a rational number, so I'm going to put it right here. And what do I go to? That's actually next in 8th grade, but you don't need, so we'll go to real numbers, but you don't have to go there. So then 3/8 is only a rational number. It cannot go in, right, because it's not an integer. It has a fraction, so it's not going to be an integer. 73. I know that 73 is positive, and it doesn't have a fraction or decimal, so therefore it's a whole number. Now, all whole numbers are integers, and all integers are rational numbers. So that one's going to be whole, integer, and rational number. Okay, so here we go. Let's move on to identifying opposites and absolute values of rational number. Remember, opposites, you guys, is basically the same digits, just with the opposite sign. So if it was a negative, it's going to be positive. If it's a positive, it's going to be a negative. And absolute value is the distance from the number to 0 on a number line. It's always going to be positive, okay? So absolute value is always, always positive, never negative, because distance is not negative, okay? So here we go. Let's look at the opposite of negative 5 over 10. Again, what's opposite? I'm just going to take those same digits, and I'm just going to keep it positive because this one was a negative. What about this one? Well, this one is a positive, so therefore I have to make it a negative. So it's going to be negative 3.9, okay? Absolute value, remember, absolute value is the same digits. The only thing that you do is if it has a negative, you take it away, okay? So in this case, the distance from that number to 0 number line is just 8.14, and it's always positive. And then what about this one? Is the same thing, okay? So with absolute value, that when they're positive, they end up with the same number, but when they're negative, they end up with the opposite, okay? So here we go. Let's work with this right here. So now we're gonna do comparing and ordering rational numbers. And for us to do that, it's better we have them all in the same form. Now I noticed I already have that one in a decimal form, decimal form. This one is a mixed number, so I want to change that into a decimal. I'm gonna keep my -3, right? Because that's just my integer, and I'm gonna change 1/4 as a decimal. Okay, so that means 1 divided by 4. Okay, so when I do that, first one in the house, 4 doesn't go into 1, so I'm gonna add a 0 here, decimal, decimal, add a 0 here. So 10, that will be 2, so -8, and then I have 2 left over, another 0, bring it down. So that's the 5, and 5 times 4 is 20, so -20, so remainder of 0. So then I have 3.25. Remember, I'm going to copy the numbers after that decimal right there. So after I do that, now I can order them and put them on my number line, and then I can see which one is the greatest, which one is the least, okay? So I have -4, so -4 is going to be right here. And then I have 5.2, so that's going to be on the right side of my 0, so that's 5. And I noticed that there are 5 little increments, so that means that each one of them is basically going to be 0.2 because, 2 tenths, 4 tenths, 6 tenths, 8 tenths, 10 tenths, that's a whole one. So then it's going to be right here. That's my second point. And then my third point is -3.25. That means that it's going to be between 3 and 4. -3 and -4 right there. So that will be about right here in the middle. Okay. So this is -4.5. This one was -3 1/4. And this one right here was 5.2. Okay. So I already have them there. I can compare and I can say that from my least to my greatest will be going this way, right? And then from my greatest to my least, I will be going from this way. Okay, and I can also say, okay, which one is the greatest? Okay, 5.2 is the greatest. Which one is the least? -4. Sorry, that should be just 4. -4 is the least one of those three. Okay, and I can also say, okay, if I were to compare this to right here, right? -4 and -3 1/4. Which one is greater? Is it greater than or less than right here? So I'm going to say, well, this one is further away from 0 on the left side. That means that it's way smaller, right? So this is less than. Okay, what if I were to compare -3 1/4 and 5.2? Well, negative numbers are always less than, right? So I can do that, right? If I do 5.2 is smaller or greater than -4, well, that's of course greater. Okay, so we can all do that. So hopefully this review helps you to be ready for your test. You're amazing. You can do this. I believe in you. Got those too. Remember, math is magical and you're awesome. Blessings.